So that was Peter Tosh from a group called the Wailers that used to tour with Bob Marley, which is one of the probably the most famous reggae band there is. Quick history on Bob Marley, interesting guy. He passed away from toe cancer. A lot of people don't know that. And the reason he passed away is because he's Rastafarian and he refused to remove his toe because in his religion it affects your entrance into heaven. So he let the cancer spread throughout his body until it took his life finally. But in this song, Peter Tosh, one of his members, is really talking about a nuclear holocaust. This idea that one day nuclear bombs could turn into more than just twice. They've only been used 2 times in history as a weapon, Hiroshima and Nagasaki, which we're going to talk about today. And America is the only nation to actually ever use nuclear weapons in war. Now, most historians are probably going to argue that this will not be the last time in history we'll use nuclear weapons. Every weapon we've ever invented or created in humanity has been used a lot of times, multiple times. Everything from barbed wire, which was invented in World War One, to technologies like the plane became a military vehicle in World War II, and we use them constantly now. Bombing, missiles, and rockets were created by the Nazis in World War II. All these weapons have been used, and nuclear bombs as well. And we're going to talk about the race to build the first nuclear bomb. And it all starts with, in my mind, this guy, Albert Einstein. So Einstein is going to give us probably one of the most powerful, profound formulas in the history of the world. E equals mc squared. And I know you've heard of this formula. I'm not sure if you've learned about it yet in science classes, but we're going to kind of break down what that means. And it is an immensely important formula. Basically, what it's saying is energy is equal to mass accelerated at the speed of light squared. So energy equals mass times the speed of light squared. Now, the big idea there is that mass, everything that has mass is energy, and energy is mass. They're the same thing. And if you know how to use mass, you can, in the right way, and we're going to learn about what's called fission or fusion, you can produce immense amounts of energy from very small pieces of mass. So something like a glass of water or a piece of fruit would have enough mass, in theory, to light up the city of St. Louis. And that's serious if we know how to do that. Now, we know how to do, we've learned how to use nuclear reactors, which again uses small amount of mass for the amount of energy you get. But we use pretty dirty types of nuclear energy called fission. And we'll get into, on the other side of this, there's the clean burning form, which is fusion, which we don't really know how to do very well. And if we do it, it doesn't produce hardly any energy, and it costs us a lot more money and energy to produce that. The formula proved that nuclear energy was possible. So Einstein had given the world the possibility. And what he finds out from other scientists is that the Nazis are quickly on their way to make a nuclear bomb. They're playing with things like nuclear with water. There's unstable waters up in Scandinavia that might be able to create a nuclear reaction. They're playing with this, and they're coming close too. And the Americans and the British have to stop this, but at the same time, we start creating our own program to beat the Nazis. And the idea is, and the theory is, and it may be correct, that if the Nazis and the Japanese had gotten to the nuclear bomb, which with time they probably would, they would probably use it regularly and without any apprehension. America used it twice, and we've had debates ever since on whether we should have used it or not. I don't think the Nazis and the Japanese would have had such debates. I think the fascist powers would have used it with this ends justify the means idea that they want to conquer the world. So Einstein talks to Roosevelt and says, look, this is the way to go. And it works. It creates a program. And what's interesting about Einstein is after Nagasaki and Hiroshima, he spends the rest of his life basically dedicated to ending nuclear warfare and nuclear energy. And we'll find out some of the consequences, like the United Nations are a consequence of nuclear energy and nuclear war. Nuclear energy is the nucleus, a core of an atom, is in nuclear fission. Atoms are split apart to form smaller atoms, and they release energy. The reason I use the word fission a lot because that's what we actually know how to do. So, a nuclear weapon is an explosive device that derives its destruction forces from nuclear reactions, either fission or a combination of fission and fusion. Almost all fission, though. We'll get into fusion. And I wonder if you've ever seen this nuclear reactor, this kind of radioactive symbol. You probably have in video games and on television. I used to actually work at Fanning Middle School, and we had this on the basement, on the outside of the back door. The reason was that Fanning on South St. Louis was actually a nuclear bomb shelter. An idea was that people would somehow, if there was a nuclear war, and we'll get into the Cold War with the Russians, people would actually run down to the basement of Fanning and get in the ground, because it's made out of brick and it's an old heavy school, somehow it's going to keep you safe. Now, how realistic is that? Probably not realistic at all. It maybe made or helped people feel safe, but if there's a nuclear war, hiding in the basement is not going to do much. You'd probably have to be buried 15 feet underground in lead containers. And then the other problem would be when you're done, you can't even come outside because it's radioactive. You'll get sick and die from radiation poisoning, which is probably even worse. So honestly, if there was a nuclear bomb being used against me, practically, I'd probably think I'd rather be in the middle of it and just get it over with. Then we'll see the consequences of people that were at the tail end or what is close to the blast, and they weren't incinerated, and they were poisoned, and radioactive radiation poison is torture. If you've known anybody that's gone through chemotherapy or dealt with it, how sick they get, and people don't even want to do chemotherapy when it could possibly stop the growth of cancer. And that's what's really interesting about nuclear energy. It's such a powerful thing. It can actually save lives because we can stop the spread of cancer by killing the cells and containing the spread of the cells within the body. But on the same, it causes cancer. This is great irony that radioactive material, radiation, causes cancer, but it can kill the cells from growing in cancer. It's just, it's such a contradiction and interesting science that could have a lot of positive and negative consequences. And you guys will debate that, whether the good outweighs the bad, I don't know. But we're going to look at fission. Fission is when atoms are split apart to form smaller atoms as a result of releasing energy. This is what we're familiar with. This is what we use in bombs and what we use today, almost exclusively, is fission. And what fission is, I like to think of it this way. If you've ever played pool and you take that cue ball and you smash that cue ball into the body of the other balls, okay, to the rack, and they explode. And the inertia and the force behind the cue ball, when it hits those balls, it just pops, and all balls blow, and they start smashing. Now imagine if there's other balls, and the physics and the inertia would just keep smashing into the other balls. That's how it works with the neuron. If we could just get one neuron and we could flick it fast enough to hit the nucleus of an atom, of another atom, and then that nucleus explodes and throws neutrons to the other atoms, it'll be this giant chain reaction. It'll just keep going until it just covers immense amounts of land and destroys things and produces tons of energy if you're using for a nuclear weapon. Or if you can contain it, you could take the energy and you could use it to turn things like lights on, or to keep your pool warm or something, or to light up the streets, all kinds of, turn your television on. So that's fission. That's what we do. And you can see it's called uranium-235 is probably the most common. We also use plutonium, which is stronger and creates a bigger reaction. And the uranium 235 is actually, it's illegal. You can't buy this stuff. It's so unstable. It's a super unstable atom, and that you don't want to play with this stuff. It's radioactive. It'll make you sick. It could kill you. Very rare in nature. Very expensive. That's why America and most countries that probably don't have nuclear power is because they can't afford the materials. We've released how to create nuclear reactors and had some strange stories about that, but the material itself is incredibly expensive, probably for the best. And you could see one true story I can think of that just blows my mind is years ago there was a 15-year-old boy about your age, teenager in high school, and he knew you can't buy nuclear uranium-235. So what he did is he bought a higher grade uranium, and he somehow knew how to actually break it down and make it into uranium-235, an unstable uranium, and he created a miniature nuclear reactor in his garage. Now, how big of a deal was this? It was a huge deal. The CIA and the FBI showed up, basically, questioned this kid, possibly could have had serious consequences because of his age. There wasn't too many. But what this kid could have done is he could have destroyed the entire neighborhood and killed everybody in the area because he didn't know what he was doing or how to contain it properly. And luckily, the CIA and FBI got to him first. The irony is, in the end, what this kid did is when he's like in his 20s, just a couple of years ago, he did it again. He tried to do it again down in Oklahoma, and they busted him again. This guy would not stop with this. How easy is it? That's not the only example. We'll talk about some other examples. Now, on the other side, you have what is called fusion. Now, fusion is not nearly as devastating as fission. Fusion is taking the atoms and you fuse them. They bring them together in a nucleus atom. But when you do this, it still releases huge, immense amounts of energy, but it doesn't have the byproduct. It doesn't have as much radioactive material, or radiation is not spreading all over the place, making people sick and killing them. Here's the problem with fusion. We don't really know how to do it very well. Whatever we do know how to do, it takes us immense amounts of money and energy to actually create fusion. So it might cost us $1 million to make $1 worth of electricity. So it's pointless at this point in history. Now, the good news is there's a lot of physicists that believe that maybe in the next 50 years or 100 years, maybe in your lifetime, we'll be able to harness fusion. That would change the game. You could honestly, there's enough energy in a cup of water that we could turn all the lights on and electrify the entire city of St. Louis for days. That's how powerful fusion is in theory. Now, if we could pull it off, it will change everything. Because honestly, even with discussions about renewable energy, while solar energy it's awesome, and so is wind turbines, they still have consequences. A, they take up tons of land. Okay. B, wind turbines, they do destroy bird migrations and do affect birds. So there's other consequences. Where fusion would produce tiniest small amount of radioactive material we could get rid of, and it would be really great at lighting up and electrifying huge areas. So it could be something that could actually save us. In one theory is that if we harness fusion, we could produce tons of energy without producing any pollution. And the irony could be the thing that could destroy us is fission through nuclear war, but fusion could maybe save us from polluting the earth to the point that we get so sick by producing tons of energy we could all use without, in fact, creating tons of radioactive byproduct, like fission does, and we have to get rid of it. And it's really expensive to get rid of. You have to bury it in lead capsules deep in the ground. So this is where it really begins. While Einstein opens the door, he gives us the key. This is the guy that builds the door and builds the entire thing. His name's Robert Oppenheimer. How intelligent is this man? He's giant. He's amazingly intelligent. So during World War II, the United States made a secret weapon called the atomic bomb, okay? And the whole program is called the Manhattan Project, and it's all over the America that's involved in this. Tennessee has something like 100,000 people in a fake town building this stuff. It's all top secret. Hundreds of thousands of people are involved in this, in the Manhattan Project. You have scientists up at the University of Chicago, Washington University, McDonnell Douglas down in St. Louis was working on this. A lot of stuff is all worked on here, Chicago, and it's tested in New Mexico, all over the country. Everybody's working on this thing. Top secret, nobody could talk about what's going on. This is the guy in charge of everything, Robert Oppenheimer. How intelligent is Oppenheimer, the guy that's in charge of the Manhattan Project? He's brilliant. He is absolutely brilliant. And it's interesting. It's a common story. Him, like Einstein, are both brilliant Jewish scientists that fled Europe for fear of the Nazis. So Einstein left Germany and Oppenheimer left Czechoslovakia because the Nazis were coming. They could kill because he was Jewish. And Oppenheimer is so smart. One of the stories is that him and the other physicists at the time, the nuclear physicists, what they would do is they would play chess. And you're like, well, that's not really a big deal. Really intelligent, regular people play chess. No, they played chess without a board. So I want you to picture that. They played chess without a chessboard. They were playing chess in their minds. That's how intelligent these guys were. They could picture the chessboard and make the moves, and then they could remember the moves of their opponent, the other scientists and nuclear scientists, and they could sit there and work on nuclear weapons all day long. That's how, without touching a chessboard. They're just absolutely brilliant. Oppenheimer was so intelligent. I think he knew something like 12 languages. Um, he was he was obsessed and loved to learn about different religions, and he really was into Hinduism. And he read what's called the Bhagavad Gita, which is the equivalent of it's the equivalent of the Bible for Christians. And he didn't want to just read the Bhagavad Gita, he wanted to read it in its original language. Well, the problem is the Bhagavad Gita is written in Sanskrit originally, which is a dead language. Nobody really knows how to speak it. We have pieces of it. And what he does, he took those pieces, he taught himself how to read the Bhagavad Gita in its original Sanskrit language so he could understand it. And in the end, he regrets everything he's done with the Manhattan Project. He did it to help the Americans, to stop the Nazis, but he realized that he'd made a bomb that could destroy humanity. And he talks about Vishnu and Shiva, and Vishnu's the destroyer of all worlds, and compares himself to the destroyer of the world, that he had given humanity the ability for us to destroy ourselves. And it haunted him. And the military turned on him in the end. They took away his clearance, and they ignored him in the 1950s, even though he's probably the greatest leader in American history when it came to nuclear war. And Einstein spent the rest of his life advocating against nuclear war. So what happened is Truman becomes president because Roosevelt dies, and at the end of World War II, he dies of a brain aneurysm. So the vice president is the Democrat Harry S. Truman. He's from Missouri, outside of Kansas City. Actually has a university, Truman University, a really good school in Missouri you could go to, named after him. And what happens is he's pretty convinced that we're going to have to use nuclear weapons to beat the Japanese. And there's a big consensus amongst his cabinet and his military that they should do this. Now, the reasons why are, the fundamental argument is this, that we're going to lose over 100,000 Americans if we invade Japan. So if we do a traditional invasion, it's going to be bad news bears. Okay, that's the biggest argument. And there's a lot of truth in that. We saw what happened in Okinawa. It's absolutely devastating to watch what happened in Okinawa. You had everything from they would use civilians as bombs against the American soldiers. There were kamikaze or suicide raids. The Japanese were notorious for flying planes and killing themselves into the American aircraft. And they would also do banzai raids where the Japanese would run at them if they ran out of bullets or weapons, they would just charge at the Americans and try to overwhelm them in numbers. And most of the time it ended in their deaths. And civilians were involved as well, so there was some evidence that maybe the Japanese, when we actually went to the mainland Japan, civilians would fight as well to kill and hurt the American soldiers. So that's one strong argument. Some other arguments historians have really looked at is maybe it was boys with toys. I mean, if you have a nuclear weapon, aren't you really excited? Was there a lot of this energy that they want to see what it does? Because we really didn't know what it did. We knew somewhat what radiation did because of Madame Curie, and she died of radiation. There's actually a female scientist that discovered radiation, Madame Curie. But we knew what happened to those scientists that were exposed to radiation early on in history, but we didn't know what a nuclear bomb would do. Was there some of this boys with toys want to see what happens? That might have been a part of it. The other thing is, hey, the Russians are coming. And the Russians are in Manchuria and China, and they're moving through Korea. And at this point, the Russians are going to get to Japan and end the war on their end. And a lot of Americans want, no, this is our boy. This is our baby. Pearl Harbor was by the Japanese, and we want to win this war. So we're gonna beat the Russians, and we're gonna take Japan. That's ours. We own Japan. That's our revenge and our consequences we want. There's that argument. There's a lot of arguments. And there's also arguments about the consequences. What are the consequences going to be? While 100,000 Americans may die, we know it's going to have mass destruction in Japan. And the way they justify it is we're going to target military objectives. And you can see there's a picture of a little boy, the first nuclear bomb. So, on August 6, 1945, a B-29 airplane called the Enola Gay, so her name is Enola and Gay is happy, she was going to drop a nuclear bomb called Little Boy on Hiroshima. or Hiroshima, Japan. You see it on the map.
Okay.
And then very quickly after, 3 days later, we're going to drop a second bomb called Fat Man on Nagasaki, Japan. And we'll talk about, this is the picture of the crew. A lot of the crew had mental health issues. And realized what they had done. There's a famous photographer took pictures of this, and he described it as the most beautiful thing you'll ever see in the world. The explosion of a nuclear bomb. I'll show you a picture at the very end. But the consequences are enormous. We know some of the consequences, and Oppenheimer literally walks into Truman's office, and he holds his hands out, and he says, "There's blood on my hands. President Truman, we have to stop." After the first bombing in Hiroshima, we used the atom bomb, and then we're going to move to a much heavier bomb, the helium bomb. And Truman takes the handkerchief from his lapel and he throws it at him, and he says, "Go wipe it off," meaning, go wipe this blood off. We're in this, and we're going to finish this, and we're going to hit them again. And they did. We bombed them again 3 days later in Nagasaki. Devastating. Both targets did not appear to have much of any military factories, as the U.S. Army claimed originally. Could have been a mistake. We don't know. Or maybe they did not care. I don't know the answer to that. We don't have enough evidence at this point to draw those claims. Consequences are atrocious. We want an unconditional surrender of Japan, and the Japanese were talking about right before we dropped the bombs, and we knew it, but we still dropped the bombs in the end. So this is the consequences. In Hiroshima, we estimate at least 90, possibly as high as 166,000 Japanese, mostly innocent civilians, died. Nagasaki, it was 60 to 80,000. And you could ask, well, why are these numbers so huge difference in terms of estimates? The reason is, well, we might know the original amount that people died. We don't know the full consequences. And the full consequences were huge. The radiation gets into the water. The fishermen and the fish they eat is radioactive. People die and get sick from radioactive poison hundreds of miles away from the rivers and the waters and the ocean. People run into these areas to help the people that are dying of radiation. And you know, and I know, you can't just run into a nuclear radioactive area. Actually, the land would be destroyed for 50 years. We now have cities there, but it would be years and years before you could even build anywhere near these areas for fear of radiation. And who knows what the consequences were. How many people got cancer just being exposed to radioactive material that was still there. So absolutely, the food they ate, everything is polluted, devastating by this. That's why people talk about an apocalypse, this idea that we could drop enough nuclear weapons to destroy humanity. And that's true. And the idea that you could just build some kind of lead capsule underground, yeah, that might work initially, but you're going to have to come above ground at some point. And what are you going to eat? And what air are you going to breathe for years and years underground? So that's why I'm sure you've all seen a lot of movies on this. So there's a picture. That's a famous picture I was telling you about, how beautiful it looks, but how devastating it really was.